Hi guys, for this challenge we want to make something wearable as a fabric with a dynamic applications such as sports, and as always put them all together with electronics. We came out with a SmartPunch, which is the concept of an engineered interior globe that it's inside a boxing or a kickboxing globe and measures the acceleration and force of each punch for tune up your training. How we do it? Well, first of all, as always, by testing the impact force in an assembled setup for the impact and then integrate it all that we'll have learned in this test in a wearable electronic. Integrated all for a wearable device. Well, part of the testing was to start simple. We attach a piezoelectric and an impact switch to a metallic ball with a known mass. The mass was assembled with a 3D printed housing in order to keep fixed the piezoelectric sensor, and measures the time of travel from the beginning to the end of a fixed distance free fall. By knowing the mass and trigger a timer on when it starts to fall and put it off when it comes to the ground, we can measure the acceleration and with the mass the force of impact for this first test. We used the circuit 1 to the impact force testing. The impact given by the free fall of the ball at the fixed distance gave us an initial voltage peaks that later we were able to relate with the force. Given the results of the piezoelectric sensors for a more accurate impact force measurement, we directly add to the setup an accelerometer, modifying the initial circuit. With this and adding reference of the mass, we were able to estimate directly acceleration and in consequence the force of impact. We measured then the deceleration in order to get the impact force that we will get. The wearable, how we do it, as always, we start the artistic design by taking some measurements of my hand and then play a little bit with clay for an initial mold. Then we hesitate between different materials to use. TPU, for instance, for flexible, and we decide to make a protection for the knuckles. The protection for the knuckles has also the piezoelectric sensors to trigger the impact of the force. This was a first example with the 4 knuckles piezoelectric sensors, and this testing of the knuckle defense protector. We passed through several iterations to get the final result for the structure we need for the wearable, testing different numbers of piezoelectric sensors and configurations of the cap for the fender, and finally some TPU testing. For half flexible parts mixed with rigid ones. The fabric. With the fabric, after struggling a little bit to integrate all the electronics and the wires and the sensor, we were able to get a nice and fancy result of a globe integrated with sensors, piezoelectric and accelerometers. As it can be observed, the accelerometer is in the back of the hand. It has a cap that it must be glued. Finally, the electronics were conformed by two systems. One is the globe, as I mentioned, and the second one consists in a small round screen and all the electronics to get the signals from the accelerometer and the piezoelectrics in order to start the training, as we can see in the video. Well, that's all. This is an undergoing project, so it's already subjected to some tests and for future works. Thanks a lot, TME community. Ciao.